Hello, and welcome back to the video lecture series for Introduction to AR Programming using Scala. In the last video, we started looking at parametric polymorphism. We're continuing on with that theme in this video, and so we continue looking at our example of sorts. So we finished the last video by making a bubble sort that took a type parameter A with the condition that A either was a subtype of or could be implicitly converted to the type ordered of A. And this made it so that our sort worked fine for doubles and ints, and it would work for strings. There are many types that this would work for. However, this approach has what I consider to be a very big limitation, and that is the fact that it only sorts things in one order, whatever their natural ordering is. Imagine if you wanted to sort, say, things like students or colors or courses, whatever, or enemies in a game. There are all types of things that you might want to sort that really don't necessarily have a good natural ordering. So for example, if I were sorting colors, well, I could sort them by their total brightness or maybe by their red component. There isn't any natural ordering for colors. Even for things where there are natural orderings for ints, right now this sorts them in from least to greatest. And that's the only way it can sort them, because the code that does the natural ordering on doubles goes from least to greatest. And in theory, I could override the implicit conversion. But if you have something that already is ordered, you're going to get its natural ordering. And so I like to have the capability to do sorts with different types of orderings. And so I want to show you how we can do that in the code using type parameters and a little bit of abstraction. So I'm going to call this bubble sort 2, and it will be parametric on just the type A. After passing in an array of A, I'm going to pass in a second complete argument list. So you should remember from part 1, and you've seen this with calls like fill. In fact, we used it right here. This was a curried method. Fill takes two separate argument lists. I'm doing the same thing here. I'm going to make this so it takes two separate argument lists. The advantage of this happens to do with type inference, and it makes it easier to use this function later. But what I want to pass into here is something that fixes my one error. My problem with the A is that I need a less than, and this doesn't have a less than. So type A as being an any doesn't have a less than for exactly the reasons we were just talking about. Student, what does less than mean for student? Color, what does less than mean for color? You don't know, and they're not well defined because some things don't have that natural ordering. So instead I want to pass in an extra argument. I'm going to call it LT for less than. And what LT is going to do is it is a function that takes two arguments of type A and returns a Boolean. This is exactly what less than does. You have first thing, less than, second thing, and it tells you Boolean, true or false. So instead of typing less than like that, I'm going to make this a call to the function. So now the bubble sort, it runs through everything, but for each comparison, instead of using kind of a natural ordering with the less than, it uses whatever function you decide to pass in. So whatever the LT function is, that's what's going to be used for the sort here. And we can demonstrate that this works if we take bubble sort 2. Now if I want to get my double sorted in the normal order, because this function is less than, I need to pass in a function that represents less than. And so the short way of writing that is underscore less than underscore. By the way, this is why the reason that I use two separate argument lists is because it can look at the type of nums and then for the next argument list figure out that because nums is an array of doubles, these underscores are doubles, and I don't have to tell it that. So if I run it like this though, we get our doubles. They are in sorted order from least to greatest. Let's go back to our util random next int 100. It's easier to read the ints on the screen. Okay, 2, 6, 8, 20, da-da-da, all in sorted order. What if I want them from greatest to least, though? Well, then instead of typing in less than, I can pass in a function that represents greater than, and all of a sudden my ordering has reversed. I could type in whatever function I want here. For example, you want a slightly different put in some spaces. I take the ints, I convert them to strings, and I do a greater than on the two strings. Actually, let's just go back to a less than. So it's would be the normal ordering, but it's not the normal ordering on ints, it's the string version of them. And how is that different? Well, for that example, it's not, because I happen to get all things that are, oh wait, nope, I see it now. There's one difference. Notice the 6 that's buried in the middle of here. Okay? That's because when you do string comparisons, the first character matters more than anything else. And so 6 is greater than 48 as a string. Okay? It is true that 6 is greater than 48 because it looks at the first character, and because 6 is greater than 4, this holds for strings. So this is something that I really could not have done very nicely. It would have been very hard to do that here with my bubble sort, with my original bubble sort where it uses a natural ordering, but here I can do this. And if instead of being ints or doubles, if the type that I had was student, I could have one sort where I do underscore dot name to sort students by their name. I could have another one where I do underscore dot grade to sort students by their grade. So that's why I really prefer this style of sorting. The ability to pass in your own ordering function gives you a lot more flexibility, and it makes it so that it works with any type that you want. We're going to see this a few more times during the book, because there are some data structures that we're going to create where you have a sorted order to them. And it's just far more flexible if you can provide your own ordering instead of having to rely on something that is natural to the type. So that's your brief introduction to parametric polymorphism. You've seen how to create classes that have type parameters on them, and we'll come back and see a lot more of this in coming chapters. You've also seen how you can make functions or methods parametric, and then how you can deal with the limitations on that either by placing bounds or by passing in additional functions to give you the appropriate level of abstraction. So that's it for parametric polymorphism. Hopefully we'll see you again soon.